This video covers section 3.6, point slope form. This is our last form of the equation of a line. It's a little bit less useful or less common than the y equals mx plus b, the slope-intercept form. But the thing about the slope-intercept form is it requires a y-intercept, which is a very specific point. This version of the equation only requires any generic point, which we're going to call x1, y1, and the slope, which we're going to call m. And when you have that information, you plug that all here into these values. So it'll be y minus the y-coordinate from your point equals m, which is the slope, parentheses x minus, and then the x-coordinate from your point. And then you have the equation of a line. We're going to do this example where we write the point-slope form of a line that passes through the point 2, -3 and has a slope of -2. This is a really easy problem because they want the point-slope form, which requires a point and a slope, and what do they give us? A point and a slope. So they literally give us the three pieces we need to plug in. So the only things to keep in mind are 2 here, this is going to be x1, and -3, this is going to be y1, just because that's the x-coordinate and the y-coordinate of the point, and the slope will be m. Okay, so that's going to tell us where to plug in, so we'll have y minus, now y1 already has a negative, so we got to be careful that we have both those negatives. Y minus a -3 equals m, which is -2, parentheses x minus x1, which is 2. This is the equation of the line, actually. This is a fully worked out equation of the line. It just has a y and x in there. All the other numbers are plugged in. It's not that easy or useful to graph from this point, but the point is it's an equation of a line. We have it. Now if you want to take this equation and make it a little bit more useful, you can actually solve it for y to get it back into y equals mx plus b. So to solve it for y, we just need to get rid of this minus a -3, move it over, and distribute this 2 through. I'm going to do that in a couple steps. First of all, y minus a -3 would be the same thing as y plus 3. And over here, we're going to distribute this 2 through. So we'll have -2x, and then -2 times -2 will be a plus 4. And then we'll just subtract this 3 from both sides. Now this, again, this last step here, this is not necessary to solve this problem, because it just said they wanted the point-slope form. But this is how you take the point-slope form and get it back to the slope-intercept form, which is very useful. Write the slope-intercept form of a line that passes through 2 points. This is the least amount of information they can give you if they want the equation of a line. That least amount of information is 2 points. So the first thing you're going to do is, any equation you have, you're going to need the slope, and that's definitely something they didn't give us. So instead, we're going to take these 2 points and we're going to use our slope formula. So this is the formula for the slope, and what I'm going to do is just label real quick x1, y1, and x2, y2. Right, that just helps us be careful about what we plug into this formula. And let's do it. So m equals y2 minus y1. That's going to be -4 minus 5, because that's what we labeled as y2 and y1. And then on the bottom, x2 minus x1, that's going to be 1 minus, be careful, x1 already has a negative, so it's going to be parentheses -2, just like that. On the top, -4 minus 5 is -9. On the bottom, 1 minus a -2 is a positive 3. This gives us a -3 as our slope. So now what we have is, we actually have 2 points and we have a slope. Think about what we wanted last time. We wanted a point and a slope, right? Now we have actually 2 points and a slope, so we have more than what we need. So we're going to start with that form, y minus y1 equals m times x minus x1. And we have 2 options here for the point to use. I'm going to go ahead and use this one because it's already called x1, y1. But you could use this point as x1 and y1, and you'll still get you'll get the same answer. So let's go ahead and use that first point though. So it'll be y minus y1, which is 5 on the point we're using, equals m, that's our slope, which was -3, times x minus x1, which is -2. That is the equation of the line in point-slope form. Don't forget, they were asking us to find the equation in slope-intercept form. So we're going to have to do that one extra step where we move the -5 over and we distribute the 3 through. So let's make a little room here. So right here we're going to, let's go ahead and, let's see, what should we do first? We'll add the 5 to both sides. And this minus a negative 2 right here, I'm just going to rewrite this as minus a negative 2, same thing as plus 2. So I'm going to put the plus 5 out here real quick, and we'll get y equals negative 3 times, this will become x plus 2, and now we have a plus 5 on the outside. And now we'll distribute that negative 3 through, and we'll get y equals negative 3x minus 6 plus 5. And minus 6 plus 5 is just a plus 1, or sorry, a minus 1. So we get y equals negative 3x minus 1. There we go. Last example here, we want to write the slope-intercept form of a line that is parallel to a given line and passes through the point 2, negative 4. So we have to recall what we know about parallel lines. Parallel lines have the same slope. So as soon as they tell you that it's parallel, what that really means is our line is going to have the same slope as this line. So the first thing to figure out is, what is the slope of this line? Well, luckily this is in y equals mx plus b, and m is 2. So since we're parallel and this line has slope 2, our slope will be m equals 2. And then we have a point. We have a point also right here, and we just figured out the slope. So why don't we go ahead and take write the equation of this line in point-slope form, and then again we'll solve for y to get it back to slope-intercept form. So we have our x1, y1 over here. We have our slope, so we have everything we need. Will be y minus y1 will be negative 4 equals m, which is 2, times x minus x1, which is also 2. That is now the equation of the line in point-slope form, but we want slope-intercept form. So let's make this y plus 4, because minus a negative 4, same thing as plus 4. We'll distribute this 2 through. 2 times x is 2x, 2 times negative 2 is minus 4. And then we'll get y by itself by subtracting 4 from both sides. And there we go. This is now the equation of a line that passes through the point 2, negative 4, but it's also parallel to this line. And we know that because it has the same slope as this line. There you go. Hope this helps. Let me know if you have any questions.